Welcome. We're going to be working on problem 2a. The instructions are, given the following points, find the equation of the line in slope-intercept form. Recall, we're trying to find the equation of a line, and we need to do that in slope-intercept form. But we're going to be starting off with 2 points. Our points are 1, 2 and 2, 3. Let's highlight those points so you see what we're working with right here. The first step is to, step 1, find the slope and y-intercept. Well, that's a one-line instruction, but it actually requires us to follow these steps that we had done in the previous problem. Slope is listed here, and the first step in the other problem was to find the slope. So it doesn't differ. We need to find the slope first. This is the equation we use. So let's set it up. Let's bring our points down, and I'm just going to lasso them, move them down here. Let's label them. I'm going to choose point 1 to be the first, 2 to be the second. So that means if this is the first point on the left, my left that is, x1, y1, x2, y2. We're going to write the slope formula. Slope equals y2 minus y1 all over x2 minus x1. We're going to substitute in now. Our y2 value is 3. Our y1 value is 2 divided by x2 is the number 2, subtract x1, which is 1. So the difference of the y values is 3 minus 2, or the number 1. This is all divided by 2 minus 1, which is the number 1. 1 divided by 1 is 1. So in this situation, slope equals 1. Let's circle this so that we remember that important fact. Now, I have a question for you. Does the slope of positive 1, does it look like this, or does it look like that? Well, the answer is it goes up to the right. We've done step 1. And now we're going to find the y-intercept. How do we do that? Well, we need to revisit the previous steps. We need to go to step 2, which is choose any point and label it x1, y1. Have we done that? Yes, we have. We have done that right here. Point 1, 2. So let's bring down the data and put it above this. x1 is going to be 1, y1 is going to be 2. Let's see what the next step is. Step 3, set up the slope formula. Box in y2, substitute in, so we're going to take this byte by byte. First thing we're going to do is set up the slope formula. So I need to write it. I'm going to do that work down below. Slope equals, if you don't remember, let's look back at the formula. y2 minus y1 over x2 minus x1. So we wrote the formula. And next step is, so we did the first part. This is the slope formula. Now we need to box in y2. Did that. Now we need to substitute in the formula 0, y2. Remember, x2 is always 0, so we're going to put a 0 here for x2. And y2 is already boxed in, so we don't know what that is yet. That's what we're going to be solving for. So we've done that. Next step, remember x2 is always 0. We did that. Substitute values in the formula for x1, y1. Okay, that's this right here. So x1, I'm going to circle it. It is the value 1. y1 will be the value 2. And there's only one other thing that we haven't substituted in, that's the slope. And we found that to be 1. Okay. Now that we know what we're going to put in the variables, we're going to just substitute that information in. So 1 will go for the slope, equals y2 minus y1, which is 2. We're going to divide that by 0 minus 1. What does that equal? Well, it's y2 minus 2 all over 0 minus 1 is minus 1. Now I want to move my 1 equals down a little bit better. I think it'll look a little neater if I do this. And I think I should move that up just a tad. Looks a little nicer, like it's in your textbook. I want to show you something interesting here. This -1 in the bottom. Let's study this a little bit more. I'll use a different pen colors while we talk about this. So this, I'm just going to show you some examples of 1. So 1 divided by 1 is equal to 1. We have -1 over 1 equals -1. And we have 1 divided by -1 equals -1. So I want to put a wall between these so you can see what we're doing here. We have 3 different options. We have option 1, 2, and 3. We could probably even have a 4th option. Let me show you that. If you look closely where I put this equal sign, it's right even with the divide symbol. So looking even closer, you'll see that if I come straight across, this equal sign and the divide symbol, I'm going to zoom in. It's kind of looking like that, right? But they're farther apart. So we have the divide symbol here and the equal sign here. They're on the same line. Okay? That's what I wanted to point out. Let's erase these details and just go back to what we had. So when you carefully write your math, ideally you would have it look something like that. So this is a positive 1. I'm abbreviating positive. This is a negative. This is a negative. We have one other negative option, and we have one over, either here or there, but what I want to point out is this is equal to negative 1 divided by 1. So sometimes you will even see the negative sign right before the bar. I don't think that's a good idea to write it there, and let me explain why. It'll become more clear. When you're in a hurry and you're writing fast as you're doing math, that negative sign can sometimes get lost with this divide symbol. Sometimes if you're in a hurry, you may go boop, boop, and it starts to look like the line. Right? If there's only like a small space between them, and you have pages of math, eventually this little negative sign gets lost in the details. And negative signs are important because what's the difference between -30 and positive 30. There's a big difference. It's a difference of, if you have a number line here, you have 0 here, negative 30 over here, and positive 30 over here. It's this whole difference. It's a difference of 60 units from negative 30 to 30. So when you have a sign mistake and you think and you forget it, a problem can be really off in the end by huge magnitudes depending on the numbers involved. So what the point I'm trying to make is, negative signs are important and we don't want to lose them. They're very small and tiny. So I'm trying to give you a strategy to not lose your negative. My preferred location for a negative is case 2 in the numerator, if possible. If you can get a negative sign up there, that's the ideal location. So let's go back to this problem and look at this negative 1 in the denominator. And just to remind you what the denominator is, it's below the fraction bar. So we have the numerator up here, and we have the denominator in the bottom. So let's bring this problem down that we have. We have 1 equals this. That's what we've simplified it to. So let's put those together over here. 1 equals what? y2 minus 2 all over negative 1. Well, negative 1 can be expressed different ways. Remember what I was going over earlier? Let me get rid of these little purple highlights so you can see a little bit better. Negative 1 in... I lost my negative sign too. Negative 1 can also be expressed as 1 over 1 with the sign in a different location. So let's do that. 1 equals, but I'm going to put this in parentheses now. And then next to that I'm going to multiply by 1 over negative 1. That's basically what we're dealing with here. If you don't see that clearly, let's do this. Y minus 2 over the number 1 times 1 over negative 1. I haven't changed it. The problem is still the same. I'm just expressing it different ways. So down here, the negative 1 is still in the denominator, just as it is here, just as it is here. Okay. You'll find that in math you're going to be working with ones in denominators or numerators a lot. Okay. We could even make this look a little different. 1 over 1 is equal to y minus 2 over 1. 1 over minus 1, right? Now remember what we learned before. We can express negative 1, this term here, differently. Let's write it in another form. 1 over 1 equals y minus 2 over 1. But this time, instead of putting the negative 1 in the denominator, I'm going to move it up to the numerator. Okay? These are equivalent equations. They are the same. Now that it's been moved up, we're going to be able to solve this problem a little bit differently. I don't really like all these fractions in the bottom, but I really don't like all the ones in the bottom. It's not how I prefer to look at a problem, but so that you see how I can move it up, that's the reason I did that. So it's unnecessary for me to write these ones down here, all below these divide lines there, where my numerators are up here. Okay, see that? So let's now simplify this. We have 1 equals y minus 2 times a negative 1. Now, when you have a negative 1 outside two terms in parentheses, in order to simplify it, you have to multiply negative 1 into the parentheses and apply it to both terms. So let's do that now. We have negative 1, which I've underlined, times y. Well, that is negative y, or negative 1y. Negative 2 times negative 1 is equal to minus 2 times a negative 1. Well, this is minus y, and then we have a negative times a negative, 2 times 1. See how I did that? I moved my negative sign in front of the 2. And then I just put my numbers together. So here we have 1 equals negative y minus a minus is a positive. And 2 times 1 is 2. Okay. There we go. That's all on one line. So this, highlighted in blue, is the same thing as this. Okay? Shall we look at it another way? I think that would be beneficial. we simplified it going down from this step to this step to this step to this step, and I was explaining how eventually we got down here, right? Well, let's take a different railroad track and show it another way. Here I have 1 equals y2 minus 2 over negative 1. I haven't changed the problem, I'm just bringing it down and rewriting it. Now I want to focus in on this. I'm going to rewrite this as 1 equals y2 over negative 1 minus 2 over negative 1. Why can I do that? Well, let's go back to your study of fractions. Is this not true? 4 divided by 2 equals 2 plus 2 over 2. Or how about this? Is this not true? 6 over 2 equals 8 minus 2 over 2. This is no different. Here we have a value of y. Y to 2 minus 2 is similar to the 8. Okay? And then we have subtract 2 over here. Now if we add a positive between these terms, which we don't yet, that is, that might go there. So we have our sign negative. Let's look at this another way. Well, not really another way. I want to just show you how this breaks apart. With this problem, 2 plus 2 over 2, we have 2 over 2 plus 2 over 2. Which equals 1 plus 1, which equals 2. What is 4 divided by 2? That was what we started with. 4 divided by 2 is equal to 2. So 2 is equal to 2, right? It's the same thing. So if you look in between these purple 2's, that one I've circled over here that's red, and this one's purple and circled, these are all equivalent statements. 2 is equal to 4 divided by 2, which is also equal to 2 plus 2 over 2, which equals 2 over 2 plus 2 over 2. And then if we simplify 2 over 2, we have 2 over 2 is 1. And the other term, 2 over 2, that's also equal to 1. So what I'm trying to show you is all this information here in this box can be expressed as two terms. Do you not see the first term here? And the second term? So here's our first, here's our second. And each of these terms that I've circled is just an expression of something over 1. In this case, -1. So let's try 6 divided by 2 equals 8 minus 2 over 2. That is equal to 3, right? 6 divided by 2 is 3, so we should see a 3 at the end. I'm going to put that over here. Well, this is equal to 8 over 2 minus 2 over 2. 8 divided by 2 is 4. 2 divided by 2 is 1. 4 minus 1 is 3. So now that you know that we can take two terms in the numerator that are subtracted and that are over one number in the denominator, we can break that apart into two fraction problems. We'll know how to take this apart. So I'm going to erase these blue, and this is the problem I want to work with. Let's bring that down here. Didn't happen, so let's try again. Copy. Paste. Now that we have this problem, let's work with it like we did before. 1 equals, we have a -1 in the bottom, but we learned earlier that if it's in the bottom, we can also move that negative sign up to the top. There's our y2, negative y2. We also know that if we have a negative in the bottom, below the 2, we can bring that up. In that case, we have a negative over a negative. So negative, negative, 2. Okay. So we have minus y2 plus 2. Remember, negative times a negative is a positive. Okay. What we're really saying when we have two negatives next to each other is, let's just make this a little more clear. This is just -1 times a -1 times 2. Okay? When you see a negative sign, you can always think it's just a -1 times the number that it precedes. So a -1 times a -1 is a +1 times 2. +1 times 2 is just 2, positive. And we generally don't write the positive, we just write 2. See that? Here we did because we're joining two numbers and we need to keep them separate. Otherwise it would look like minus y2, 2. Now this reminds me, in solving this problem, we have this little tiny subscript here, 2. You may be tempted as a student to write a large 2. Well, let me warn you right now, these are not the same. Little y sub 2 and y times 2 are not the same. This looks like, right here, this looks like 2 times y, or y times 2. Or another way of expressing it, y times 2. Well, the reason we stop using symbols like this in middle school is because, well, first of all, this could be y.2, this could be yx2. If you draw your x's bigger or smaller, it has a totally different meaning. If we're going to be using the notation y sub 2 or y sub 1 or x of 1 or x of 2, y of 2, y of 2, see the language there? If we're going to be using that, we have to be darn sure that that 2 is little tiny and in the subscript, so it does not ever become a large 2 and suddenly the problem is changed. For example, over here I have y of 2 or y sub 2 minus 2. Well, if my 2 gets larger, suddenly my problem becomes y times 2 minus 2. That's totally different. So what I'm trying to emphasize here is, if we're going to be using a subscript in our problems, you better be darn sure it stays small throughout every step. If you don't, you suddenly change the problem to what it never was intended to be. See, even here I'm starting to get a little bit larger, and it's starting to appear like a 2 right next to the y. Here it's definitely small, but even math teachers can get a little careless in the size. So why am I mentioning this? Up here we had to differentiate or distinguish between the 2 points, 1 and 2. Here we have 1, and here we have a 1, and then of course 2 is shown in green. Now if we could put our 2's in different colors, and assuming you're not colorblind, that would be just fine, but it takes a lot of effort to write numbers and different colors in the same problem. We typically have one color pencil or one color pen. That's the way it's been for hundreds of thousands of years. My point is, the math world has changed. You're lucky that you're seeing how many colors do I have here right now? Blue, green, yellow, and red. You know, we view the world differently. In fact, nowadays we're manipulating things in 3D space with holograms. I'm doing this math problem with a stylus on a computer tablet, and then I'm uploading that to YouTube, and you can watch this. So my point is, the world is much different than when I grew up, and technology has changed it. But the basics of math have not changed. If you write your 2 too big, and it's next to the y and it becomes 2 times y, you've changed the problem, and that's a problem. So use whatever tools you have at your disposal to prevent that from happening. Now, we can't let computers do everything for us. We have microwaves that can cook your food in 1 minute, but the bottom line is, if you keep that in the microwave too long, you're going to overcook that hot dog and it's going to blow up. It's not going to be fun. It's not going to taste good either. You need to slow down and cook it on maybe 50% heat in the microwave. Or if you're out on a barbecue grill and you're cooking hamburgers and hot dogs, if you leave them and don't come back for 5 minutes and don't carefully flip those burgers or roll those hot dogs, you're going to have a charred mess at the end. The same is true with your 2's and your negatives. You have to be very careful and attentive to this food item or this math problem. I almost honestly prefer, if you, after you've set up a problem and we have slope equals y2 minus y1 divided by x2 minus x1, if after you've done that you only have one variable and we have a subscript of 2, and you think you can remember that it's there without writing it, that's preferred, just to remove it. And so I'm going to do that at this point in time. If I'm not trying to distinguish between different y values now or later on in the problem I'm solving at hand, and if removing this negative 2 will help me avoid confusing it with a 2 times a y, it's a darn good idea to do that. So I'm going to do that at this point in time. I have 1 equals minus y plus 2. Okay? There's no other y's in this equation. There's no reason I need to keep tracking its distinction from other y's in the problem. That's the point I want to make. I'm going to circle this and we're going to compare these two results. They're the same. We have 1 equals minus y plus 2 over here highlighted in blue, and we have 1 equals minus y plus 2 highlighted in green. We took 2 different paths to get here. Starting here, and we eventually got to our answer. I'm going to separate these 2 paths. And can I make another point right now? In our problem set, I created, let me erase this, I'm sorry. I created a table of 3 boxes. And I simply put them next to each other. And I said, I think I wrote step 1 here, step 2, step 3, step 4, and step 5. And I did that for each one, right? Well, The reality is, that's just to help you remember that there's 5 steps involved in this problem. And if you can do all the work that we've just done on one line, below each step, 1 or 2 lines below each step, more power to you. Here's an example. If you can put 1,000 kids into a school bus and expect to move around and have a conversation with your friend at the front of the bus, more power to you. But the reality is, if you try to cram 1,000 things into one little tiny box or one little school bus, not much work's going to get done. Everybody's going to be stuck in their little spot, and you're going to lose some things. Let's say you drop your contact lens. Are you going to find it? Fat chance. You know, someone just stepped on it. You just lost your negative sign. Okay? That little tiny negative sign just got lost in that school bus of 1,000 kids stuffed in. It's not going to happen. My advice to you, start your problem in the box, and then you're going to need to invest in some notebook paper. One ream of paper, 500 sheets. One ream of paper is 500 sheets. Or you can get a notebook that you can spiral bound and keep it nice and organized, so when you go to the next page it's not going to get lost. You're going to number your pages. Let me show you an example. This is what I do. And I've been doing this for years, and this is how I keep organized. Please listen closely. At the top of each page, you have a white space in your notebook. And you have all your lines, right? The whole point of that white space at the top is to give it a title of some sort. Okay. So even if these are spiral bound together, okay, it's a great idea to keep organized, to number your pages. I don't care if you number them in the bottom, 1, 2, 3, 4, or in the top, 1, 2, 3, 4, or in the middle, 1, 2, 3, 4, or in the middle up here, 1, 2, 3, 4, just as long as you do it consistently the same. That's what's important. So when you look at the page, you always do it. My preference over the years is to stick it up in this corner. Okay? Every page should be numbered for a homework and assignment. If you have 10 sheets of paper associated with that homework assignment, I want to see a number 1, a number 2, a number 3, and a number 4. Somewhere on that page in the same location. The next thing I want to see when you're all done, let's say we start our homework page. We don't know when we're going to end with the problem. We're going to start on page 1. It may take us 16 pages to finish. Well, once we get to the end, we need to remind ourselves that we had 16 pages associated with this problem. Am I being facetious? Am I kidding you when I'm saying that some math problems take 16 pages? No. My goal is to give you 1 or 2 page math assignments. But the reality is everyone writes smaller or bigger. I do not recommend small. When things get really small, you have to have a microscope to read it, and when negative signs are microscopically small, they're easy to lose. You carry around something small like a iPhone. You know, these new iPhones, they have these earbuds, you stick them in your ears, and they're not attached with wires anymore. How easy is it to lose that? It's not too hard. You have to be very careful. Just imagine if they're really, really tiny, and you know, you're talking with your friend, next thing you know, where'd my earbud go? It's gone. Well, the same is true with page numbers, same is true with negative signs and other things in life. So to keep track of things, we create systems. So at the end of numbering these pages, I want you to do something like this: 1 out of 4, 2 out of 4, 3 out of 4, or 4 out of 4. That's one way to write it, or 1 of 4, 2 of 4, 3 of 4, 4 of 4. What do I mean? There's 4 total pages in this homework assignment. At the end, you figured that out. And this is page 1 of that. So now if you ever lose a piece of paper, what if you lost the last page? Did you originally have 3 pages or 2 pages? Well, when you're walking around with 5 different homework assignments, which homework assignment does it go with? Is it the packet? Let's say you have 2 assignments that end with 2 pages. Does this page that fell out of your notebook or didn't get stapled together, was it associated with the first assignment or the second one? They both had 2 pages. Well, this one system might help, because 1, you're giving it a title, and assignment 1, page 1 of 2, tells you that this assignment has 2 total pages and you're on page 1 of it. Okay. I'm going to get off my soapbox a little bit about trying to work a problem in a little tiny box. How many of you live in a home with more than 1 bedroom? Could you imagine your whole family sleeping in 1 bed like they did back in the 1800s in their small cabin out in the forest? They learned to be organized and frugal, and they learned to keep things in their place. A different mind step than we have. Sometimes we have overflowing, going off on a tangent here, but overflowing houses, garages, and storage sheds of stuff. And so that's why our mom and dads want us to clean our rooms and keep them neat and organized. I expect the same in your math. So I've been talking now for 54 minutes. If you've been able to listen to this the whole time, wonderful, because I'm providing you some good information that will help you. Let's go back to our problem. We ended up with this equation. Okay, we need to simplify that more. 1 equals minus y plus 2. Okay. We need to get y by itself. How do we do that? Well, we're going to remember that we have an equal sign here. And you've probably heard this analogy before. Here is our scale. Okay. And we put 2 hamburgers on this side, and we put 2 hamburgers here, and that's if they're quarter pounders, then that's a half a pound of meat, and bun, lettuce, and tomato, etc. on each side. And so this is equally balanced. You have a friend who's 100 pounds and you're 100 pounds. If you were sitting here, you would equally balance. No one would tip the scales in one direction or the other. The equal sign is very similar to a balance. We have to keep whatever's on one side of the equation balanced with the other side. So whatever's here on the balance has to balance out this. That's what equals means. Both sides are equal. Equal in weight, equal in number. Okay. Otherwise, we would use a different symbol. We would say something greater than, or less than, or less than and equal, or equal to, or greater than or equal to. Okay, we're not using that symbol. We're using the equal sign. So we need to be careful and make sure whatever we do on one side, we do to the other side. If we add 2 beans to the 1, we need to add 2 beans over here. Okay? So with that said, let's continue to work down this problem. I'm going to change pen colors here because I have the modern day technology. I'm going to subtract 2 things on this side. But because I have my equal sign, and I remember that if I'm going to keep things equal, I know I need to subtract 2 things over here. Now, I just put a -2 here, but remember that I had a 1 here. I need to put the plus in front of the 1 now. Because I don't want 21. I don't want -21. I want -2 plus 1. So that's our next step. Is to, why did I subtract 2 on this side? Well, I had 2 things. I wanted to get rid of them. The only way to do that is to subtract 2 on the other side. And what's the point of that? The point of it was I want to make that 0. Anything plus 0 is just that self. It's just itself. If I have a brother and sister that I'm not getting along with today, and I prefer to be alone, well, they're going to need to go to another room. Right? Well, that's basically what's going on here. They're moving to another space on the other side of the equal sign. Okay? Hopefully you get along with your siblings. They're all you have sometimes. So we have negative 2 plus 1 is equal to minus y plus 0. We don't really need to write that. Let's do minus 2 plus 1 is negative 1 equals minus y. Okay. So now I have a negative on each side of the equation. I would like to get y by itself. So let's remember what negative 1 equals negative 1 times y. Right? Let's do an inverse operation. Let's divide both sides by negative 1. That'll get y by itself. We can't add 1 to get y by itself. That doesn't work, because this is negative 1 times y. Okay, I'm going to put a little dot here to remind you. That's negative 1 times. Another way of saying that's negative 1 times y. Well, what is the inverse operation of times? It is division. Okay. We do an inverse operation to get rid of negative 1. The inverse operation of times is not plus. It is not minus. The opposite of division is multiplication. The opposite of subtraction is addition. Okay? Always remember that. Let's come back to this problem. So we have negative 1 times y. Now, did you see that right there? We have negative y. Did you think that we have negative 1 times y? That's what's going on there. Okay? Now that you see that, we know the inverse operation to remove the negative 1 in front of it. That is division. So I'm going to divide both sides of the equation by negative 1. Remember the balance? Don't forget the equal sign here. Whatever I do on one side, I have to do on the other side. We have to keep it equal. This is where the magic happens, okay? Negative 1 divided by a negative 1 is a positive 1. Equals negative 1 divided by a negative 1 is a positive 1y. Okay. We don't need to write the plus in front of the 1, because there's no other numbers nearby. 1 equals plus 1y. We could say plus y, but we don't really, there's no number in front of it, so we're just going to write 1 equals y. It's easier to see it this way, so I'm going to flip. You can imagine just rotating it around, okay? If we're looking from the top down, okay? There's our y, and there's our 1. So y equals 1. Okay, now that you know that, let's go back and discuss what we were trying to accomplish in the first place. Reviewing the steps. We took slope equals something. We put in some values from the problem with the points we had, and we determined it was 1. Okay. Then we set up the problem. We substituted in 1, 0, 1, 2, and a question mark. We weren't sure what y sub 2 was. Well, we just found that out. Okay. Y sub 2, if we had a 2 here, is equal to 1. Okay. That was when x was 0. Remember we set up in the problem? We said let x, y sub 2 be something we don't know yet. Let x sub 2, its partner, be 0. When that's the case, we solved and found out y equals 1. So here's our point. We have 0, 1. That is the y-intercept. Remember, y-intercept is wherever a line crosses the y-axis. I'm going to label my axis here, y and x. X is horizontal. I'm going to highlight that in blue. Y is vertical. Highlight that in green. Wherever the line crosses the x-axis is the y-intercept. I'm going to draw some different lines. Okay. And I'm going to draw a dot at each y-intercept. There's a y-intercept here, 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 and here. It's where two things cross. The line crosses the y-axis, which is just a vertical pole on the Cartesian coordinate system. Y is the pole, x is the ground. It's the flat part. So, when x is equal to 0, y is equal to 1. X is 0 at this point. X is not equal to 1, x is not equal to 2, it's not equal to negative 1, it's not equal to negative 2. When x is 0, this is the value of y. Which line could be represented by this problem? Well, it would be this one. I'm going to highlight it in purple, pink. This could be the point 0, 1. And because there's a point above this, that could be 0, 2. This one down here could be 0, negative 1. That might be 0, negative 2. And that could be 0, negative 3. Everything below the x-axis, this is the x-axis. Everything below the blue line, the x-axis, is negative values for y. Everything above it is positive values for y. That's a review of information that's been taught you previously, I hope. So, going back to our steps. Step 1, find the slope. We did. It was equal to 1. It's right here. And the y-intercept. Well, we just found the y-intercept. Okay. Find the slope and the y-intercept was the first step of our problem. We used these steps, slope, etc., to find the y-intercept. Let's remind ourselves of that value. Y-intercept is 0, 1 as a point. Okay. I'm going to write that down. Slope equals 1. The y-intercept is 0, 1. Okay. Did we finish all these steps here? Step 4. Solve for y of 2. We did that. Write y-intercept in coordinate form. We did that. We gave it the point 0, 1. And the equation in slope-intercept form, y equals mx plus b. We can do that now. We have enough information. Let's do that. If it's okay with you, I'm just going to do that off to the side here. Y equals mx plus b. Well, we know the slope is 1, so let's just put a 1 there, 1x. And we know the y-intercept, which means another word for that is the letter b. That's the symbol we use to associate with the y-intercept. It has a value of 1, positive 1. Okay. So if we were to give this a variable name, 1 is equal to b in this point where x is 0. So that's our solution. I can simplify it a little bit more. Y equals x plus 1. I'm going to put a box around that. So in slope-intercept form, we know m, we know b, we keep y and x unchanged, and that's the equation of the line represented by the slope and point. Check our work. Well, we can do that. Let's substitute in a point that we know is on that line. When we started the problem off, we had we had the point 1, 2, and the 2, 3. We have another point, we have 0, 1. We have 3 points now that we know about, because we knew this was a linear equation and these 2 points were on a line. We know 3 points. Now that we have an equation, we can have unlimited number of points, but we're going to test it with, I think it would be appropriate 1 or 2. Let's do number 2. Y equals x plus 1, right? Well, the x value of 0.2 is 2. So y equals 2 plus 3, which is 5. Y equals 5. Does that make sense? Well, in this point 2, it says the value should be 3. How did I get 5 when the point says it should be 3? Well, that tells me I've made a mistake. Where did I do it? I'm not sure right now. Must have had a sign error. It's unclear at this point. Maybe we got talking about too many other things and we just made a mistake. I substituted in the x value, that's right, 2. Oh, I wrote plus 3. Did you guys see that? Somehow I wrote a 3 there. That's not what the equation said. Y equals 2 plus 1 equals 3. Yes, that matches. So when x is 2, y is 3. That's shown by the point 2, 3. So our equation does work. At least for one point, let's try 1. Y equals 1 plus 1, which equals 2. Yes, that's true. I have the point 1, 2. Let's try another one. Y equals, when x is 0, 0 plus 1 equals 1. Is that true? Yep, 0, 1. So in all three instances, this equation predicts accurately the points. That's what we wanted. So check your work. Fifth step, check your work. We did it. Substitute an x value in equation and see if y value is correct. So we've done half the problem so far. Okay. So right now I know I have a correct slope. I know I have a y-intercept that's right. And we have an equation that we feel comfortable with. Now, we were given the slope-intercept form of the equation. That's this right here. Let me draw your attention to it with a big star. This is a helpful equation to memorize. Okay? This is also important to memorize. The slope formula. Okay? But we're going to derive the equation of the line differently now. That's the point of these three steps. The first step was to find the slope and then the y-intercept. Now, in the previous problem and what we just did now, we then took that information and substituted into this equation and came up with the equation. We're going to approach it differently now. This is what I would call, if you played an instrument and you've practiced your scales or your arpeggios, if you're playing basketball and your coach says, I want you to stand at the free throw line and shoot baskets one after the other all during practice. That's all I want you to do. He's trying to perfect a skill so that when you have a ball game and you get that last second foul before the end of the game and it's going to decide the winner or the loser, well, free throws wins ball games. He is trying to perfect your craft in sports so that you can win the game and make $1 million and live in a mansion and be called Karl Malone Jr. Okay. So we're trying to help you be prepared by going through these last three steps. Okay. We already know the answer. We have an equation of the line. The equation of the line we determined was right here. Y equals x plus 1. But I want you to obtain it with a different method. And this will help you practice your mathematical skills of algebraic manipulation, which is all we've been doing up to this point. Let's open up and do steps 2, 3, and 4. I need to copy this. And let's move it down to the bottom of the page, so I have some room to work. We've done find slope and then y-intercept. Okay. Remember, slope was equal to 1. The y-intercept was 0, 1. Okay. Step 2. Substitute the slope, y-intercept value. And here I'm specifying the y-intercept value is when x is 0. See the 0 here? And we have a y sub 1 of some value. Well, we learned in the previous example it was y sub 2. Here we're going to call it y of 1. Okay, and I'll make that, it'll be more clear why. Just realize in this problem we're going to be using y1. Okay, substitute the slope. This is the slope, n equals 1. And some unknown point in the formula. Okay, let me set this up so you understand what we're doing here. Before we had slope equals y2 minus y1 all over x2 minus x1. And we boxed out the y2. We substituted in different values for the other terms, and we solved for y2 equals something. And we ended up learning it was equal to 1. Okay. Well, this time we want to create an equation of the line of the form y equals mx plus b. Okay. We don't know the term. We do know the term of the slope. That's given here. We know the value of the y-intercept b. That's here. We should get the same exact answer. But what I want to point out here is we have a y term and an x term and two numbers. Okay. So in setting this problem up, we're going to have y. Let me start. We have slope equals y2 minus y1 over x2 minus x1. In this instance, we want to keep a y and an x. And we're going to choose these two. We're going to need them to not be substituted in with values. So no values will be put in for these two terms. Because we want them, in the end, to stand alone as a y and an x. Okay, so we have one equation with a y and an x term with no values put in. That means we're not going to put numbers in them. We're going to leave them as the letter. variable. The two unknown values. Okay? That is what is meant by an unknown point, x2, y2. Just noticed an error in my instructions. Or did I? No, I'm mistaken. I should be circling these two. These are the ones we're going to leave with no values. Okay? The reason we're choosing these two is because it simplifies the math and the manipulation. We could use these two, but when you have negative signs in front of a variable, it complicates things, as you saw before, right? So I'm choosing to use these y values, y2 and x2, okay? Because it simplifies the math, and that'll become more apparent. We'll solve it two different ways so you see why. One is a little bit harder. Let's substitute in our math numbers now. I like blue still. Slope equals 1, we know that. This time we're going to leave y2 by itself. And just so I don't get confused, I'm going to drop that 2. I'm just going to write y. Minus y1. Well, we had a y1 before. We can't use this point because, well, could we? I think we're supposed to use that one. That's true. See? They want us to use x1 equals 0 and y1 equals something else. Or 1. So in this situation, we're going to substitute in y is, where is that? Substitute in a 1, all divided by x minus 0. We could perhaps use another point, but this simplifies matters, does it not? I'm curious about that. We'll check into that later. But here we have a y and an x by itself, so that we can have a y and an x in our equation. We put in one point that we know of, which is 0, 1. So we put 1 up here in the numerator where the y value is, and we put 0 in the denominator where the x value is. Now we have this equal sign. We need to keep things equal. To remind myself, I'm going to draw a line and down the middle. I'm going to put some parentheses around these two terms, just so I can think of them as one unit or group. Whatever I do to one side of the equation, I have to do the other. Now, we have this symbol here. It's called divide. The inverse operation of division is multiplication, remember? So I'm going to try to get this out of the denominator, and I can do that by multiplying it in the numerator. Now if I multiply it in the numerator on one side of the equation in order to keep things equal, balanced, I have to do it on the other side. Okay. What I have now is x minus 0 times 1 equals y minus 1 all times x minus 0 over, and I'm just going to slide that over so you can see that this is like 1 over 1 equal 1, right? Or 2 over 2 equals 2. Or like 3 over 3 equals 3. Okay. Just trying to show that these are two different problems. You will find in math that when we see something in the numerator that's exactly what's in the denominator, we will sometimes just draw a little arrow through it and we will say 1. That's just to remind us that that turned into the value 1. You will also see situations where if it's not 1, you may get something like 0 over some number 2, and we will just put an arrow through and say 0. The advantage of zeros is 0 times anything. 0 times 1 equals 0. 0 times 2 equals 0. It's just a quick way to say, remind yourself with that arrow that whatever that 0 is multiplied times is 0, okay? We're not doing that now. But we've turned that into 1. Let's look at the left side of the equation over here and rewrite it. So we have x minus 0 times 1 equals y minus 1 times 1. Okay. Multiplying 1 in and 1 in to our grouping symbol yields 1 times x is 1x minus 0 times 1 equals 1 times y is 1y minus 1 times 1. Okay. 1 times x is x. 0 times 1 is just 0. 1 times y, let's just write y. 1 times 1 is negative 1. X minus 0 is just x. Sorry. Y minus 1. Well, we have y minus 1. What's the inverse operation of subtraction? It's addition. So that's why we're going to add 1 to both sides of the equation. Remember our equal sign here? We're going to add 1 here, and we're going to, you can do it this way, x plus 1, or if we're doing it on the same line, we're just going to do plus 1 plus x. Okay? Now here's where I'm going to show you this arrow. That's equal to 0, right? One plus x is equal to x plus 1, which equals y plus 0. Okay? X plus 1 equals y. I generally like to think of y as on the left side. It's just easier for my brain. So I'm just going to do y equals x plus 1. That's the equation we found. By picking a y and an x and putting them in these positions. Putting in another point. Here we put in the point 0, 1. And our slope was 1. And then we simply simplified it and got y by itself on the left side of the equation. And we've developed the same slope intercept formula that we did previously. If you go back up to the top, that's what we found. Y equals x plus 1. So we practiced our math skills. Good job. And we came up with y equals x plus 1, the equation of the line. We know that this works because we've substituted into it before and it has been found to be correct. And that is the next step. Solve the equation for y2. If you see an x over x, that does equal 1. We didn't put numbers into x2 and y2, but we left just as x and y. We wrote the final answer in the form y equals mx plus b. We did. And we checked our work. Previously. So we have done everything that we were asked to do. And then some.